Methods of producing or generating induced EMF. What is the expression for induced EMF? It is d phi over dt. What exactly is phi? Induced EMF is basically minus d phi by dt, and the flux is what? Ba cos of theta. So if you change any one of these three terms, that is either you change B, or you change the area, or you change the orientation, that is theta. In case you change any of these three things, then there will be an induced EMF produced in the whatsoever coil, loop or rectangular conductor anywhere. Okay. Now let's do some examples, short examples, how we can change these things. First of all, let's do about changing magnetic field B. How can we change magnetic field? We have a circular loop here having a galvanometer attached with it, okay, and we also have a magnet placed here, right? So when I move this magnet close to this loop or away from this loop, while doing this thing repeatedly, I am moving this magnet closer and away from this loop, the magnetic field associated with this and the magnetic flux associated with this loop keeps on changing. That is what you call as changing magnetic field, and that will result in production of induced EMF or induced current in this coil, the presence of which can be noted down with the galvanometer. Okay. Number 2, by changing what? Area. Guys, this is another case of motional EMF. See, this time I will do it in a very different way. We have this magnetic field vertically inwards, and this is the loop. This is the rectangular loop where this arm AB can be moved. Okay, let us say this length is L and this loop is taken out with velocity V. Let us say this velocity V is doing what? It is moving this part outside this magnetic field, or due to which the change in area or the change in this part, which is x, will be this much. Or if I have to find this length dx, okay, this would be more clear. If I have to find the value of dx, that is the small distance moved by this wire due to the velocity v, the distance is velocity into time. So this particular distance dx can also be written as v into dt, that is velocity into time. That will give me the value of distance. Now instead of writing dx here, I have written, I will straight away write v dt, right? This is more clear. Okay, what is induced EMF? Induced EMF is d phi by dt. Magnitude of induced EMF, the negative sign shows the direction, right? That's why I put those what is this modulus sign in front of it? That is why, because I am taking the magnitude of induced EMF is given by rate of change of flux d phi by dt, that is change in flux upon change in time, right? Or d by dt of change in flux. That is acceptable. After this, what is change in flux? Change in flux is d upon dt. Change in flux is magnetic field into change in area. Irrespective of the fact that whether area is increasing or decreasing, we have to have the change in area, right? Change in area. Now, what is change in area? Initially the area was this much. Initially we had this much area, and due to the movement of this arm, area has increased this much. So total change in area will only be this much part, which is length, this length into this breadth. So that will give me the area, that is increased area or the changed area. So now the expression becomes d over dt b multiplied by what is change in area? V dt, right? No, this is not right. V dt is not the change in area. V dt is only the this much length. What is the area? This length into this length. So this part is length, this length is L and this length is V dt. Now this is complete. Now B, L, V are constants, take it out, you are left with dt upon dt. So what will happen? Induced EMF, the magnitude of induced EMF is B, L, V multiplied by B, L and V. These three terms are constants, take them out, you are left with d over dt of dt. You will be left with what? Nothing, 1. So this is your answer. For those students who are good in maths, you might get confused with this particular d. Basically differentiation of change in flux is d phi. So I shouldn't have mentioned this d. Okay, the d phi itself is the change in flux. Okay, so this d is irrelevant actually. But writing only dt is sometimes also known is also termed as irrelevant in mathematics. So instead of writing dt here, what you can do, you can only write change in time. But here at the end you can do this 1 upon dt. So this dt now these terms are clear, because I wanted to represent d phi by dt, and d phi itself is change in flux. So that d I have omitted. So now this is right.